This is Algebra 2, Unit 12, Lesson 3 on adding probabilities. Now, there are times that we want to determine the probability that either event A happened or event B happened. So to do this, we need to be able to account for all the outcomes that fall into either one of the two events. So let's see how this looks in a simple Venn diagram. All right, so let's look at the spinner. Consider the spinner shown below that has been divided into 8 equally sized sectors of a circle. So here's your spinner. The spinner is spun once. In this experiment, we will let A be the event of landing on an even, and then B is the event of landing on a prime. So A will be even, and then B will be prime. Okay, so let's go through our list and see what we have. All right, now, we have to take into account when we do this of where the overlap is going to be. All right, so let's start with number 1. Is 1 even? No, it's not. Is 1 a prime? No, 1 is not considered a prime number. So 1 is actually going to go out here in this set. All right, 2. 2 is even. Is 2 also prime? Yes, it is. All right, so 2 goes there. All right, let's go around 3. Is 3 even? No. Is 3 a prime? Yes, it is. So that's going to go in here because it's only prime. It's not overlapping with any of those. All right, let's go through the rest. 4 is even. Is 4 a prime? No. 4 is even but not a prime. Would go here. 5 is not even, but it is a prime. Goes over here. 6 is even, but it's not a prime. So that's going to go over here. 7 is not even, but it is a prime. Goes over here. And then 8 is even and also not a prime. Okay, so that's what our diagram would look like. All right, now notice on this that the overlap right here, we do have a number that is both even and prime, so that is the overlap. All right, so when we have 2 or more sets, we can talk about their union and their intersection. So their technical definition is given below. All right, so let's use our sets and talk about union and intersection. All right, so remember our sets, we had an overlap of 2. This was 4, 8, and 6, and this was 3, 5, 7, and then 1 was out here. Okay, so for 2 sets A and B, their union, which is OR. So if you are saying A or B, which is, this is the symbol for union, X is an A or B, so that would be the values of anything that is either A or B. Okay? Union, think, unite, you put them together. Intersection is what they have in common. So think union, think, unite. Intersection is what they have in common. Okay, so the union part of the circle will be the part of the circles here. So it would be all of this, but this is only counted once. All right, the intersection is this part right here. It's the overlap. So when you do that, so the symbol for intersection is the upside down U. It looks like that, and that would be there. All right, so union is put them together, and then intersection would be what they have in common. All right, so let's look at a couple examples. All right, so from exercise 1, write out the following 2 sets. A or B, which is the union. So we would write A union B is equal to, well, we want to look at the sets. What's in A is 2, 4, 6, 8, and what's in B is 2, 3, 5, 7. So it is all of the numbers except for 1. Now notice 2 is in both of them, so we only write it once. So A union B is going to be 2, 3, 4, 5, 6, 7, and 8. Anything that's either in A, B, or both. Okay? And A intersection B, the upside down U, is what do they have in common? Well, if I look at my sets here, what we have in common is the number 2. That's the intersection. All right, so union is what's either an A or B. If there's something where it overlaps, you put them together. And then A intersection B is going to be what they have in common. Now, from exercise 2, why is the equation, the number in A or B, equal to the number of A plus the number of B generally not true? Okay, well, let's think about this for a second. The union right here is 2, 3, 4, 5, 6, 7, 8. But A had 1, 2, 3, 4 in it, and B has 4 in it, but what are we counting twice? We're counting the 2 twice. Okay, so set A and B both include 2, but we only count it once. Set A and B include 2, both of them. So both include 2, I should say. So we only count it, but we only count it once because that it overlaps. All right, so to correct this modification, if we want to know the number for A or B, which would be the union, it's equal to the number in A plus the number in B, and then subtract what they have in common, which would be the intersection. So that would be the union. So in order to do that, if you took each individual one and subtract out what they have in common, you'd be taking one of the ones that you already counted away. So that's what it comes out to be. All right, now two-way frequency charts give us a great example of how events or sets can combine or union and overlap intersection. So let's take a look at this and develop some ideas about probability along the way. So exercise 4 says, a small high school surveyed 52 of its seniors about their plans after they graduate. So here's 52 seniors right there. They found the following data and wanted to analyze it based on gender. In this case, if we pick a student at random, we can place them in one of 4 events. M stands for male, C stands for going to college, F stands for female, and N stands for not going to college. So here is the data that they found about that. All right, so give values for each of the following. So what is the number of males? Well, total number of males would be down here, would be 30. All right, the number of females would be 22. All right, the number of going to college, which would be C, right there is 29. And then not going to college would be 23. Okay, now here's where you have to be careful. What is the number of males who are going to college? All right, so we have to see where male and college intersect. So that would be 16. Okay. The number of females going to college. So female and college would be 13. All right, now, here's where it gets a little tricky. The number of females, either the number of females or the number going to college. All right, so the number of females would be 22. So that's right there. And the number going to college was 29. But when I did this column here and this column here, what did I count twice? I counted 13 twice. So I'd have to take out one of these. So I'm going to minus 13 right here. So 22 plus 29 minus 13 is equal to 38. So basically what I did was, when I added these together, you have to be aware that you have to take out the intersection. All right, this is, when you added this one, I've added 13 twice, so I have to take one of them out. So 22 plus 29 minus 13 is equal to 38. All right, so now that we know all these values, what is the probability that a person picked up at random would be a female who is going to college? All right, so we want the probability of getting a female going to college. Female and college. So and would be an intersection. All right, out of the total number of students that there are. All right, so it's the number of females and college out of the number in the total. Okay, so there was 52 students total. And what was the intersection? Females in college was 13 out of 52, which is 1/4 or 0.25. Okay, what is the probability that a person picked at random would be female or someone going to college? All right, now if we want to figure this one out, the probability, female or going to college. All right, so we would have to do female or college. We decided was going to be the 38, which would be this here. Okay, which would be 38 out of the total, which would be 52. All right, so this would be 38 out of 52, and that becomes 0.73 if you want to work that out. All right, so what we did with this is we would have to do, for the union, it would have to be F, or N of P of F, the probability of getting female plus college minus female and college. So we have to subtract out the intersection. So to do that, it would be 38 out of 52. All right, so you have to do the and the or. All right, now, explain why P of F or C does not equal P of F plus P of C. Again, because certain people fall in both categories. All right, because we have the overlap. All right, so P of F, we know is probability of getting F was 22 out of 52. And then probability of getting college was 29 out of 52. When you add that together, that's more than 52. There's overlap there. 2 and 9 is 11, 1, 2, 3 is an overlap. So it's going to be too much of a value. Or, yeah. So when you add those together, it's going to be an overlap of that, or excuse me, this is a P of C. Going to college was 22. All right. So P of A or B, which also can be read as a union, P of A union B can be written as, either way, P of A plus P of B, and then you want to minus out the intersection. So this is the overlap. So you have to be careful when you're adding this that you have to take out the overlap. All right, sometimes we can avoid the probability law that we encounter in E by simply keeping careful track of what elements of the sample space are in both of our sets and making sure we don't count them twice. Okay, so you have to be careful of the overlap. That's the overlap, and you don't want to count it twice. Okay, so a standard six-sided die is rolled once. Find the probability the number rolled was either an even or a multiple of 3. Represent this problem in the sets involved using a Venn diagram. All right, so if we take a look at a Venn diagram for this, so I'm going to sketch myself a Venn diagram. All right, I either want an even number, so this is going to be my evens, and this will be my multiples of 3. Okay, now a six-sided die, let's go through the list. All right, we start out, you can either get your set is going to be either the numbers 1 through 6. All right, so 1, is that an even or a multiple of 3? Neither one, so 1 would go out here. 2 is even. Is it a multiple of 3? No, so 2 would go in here. All right, 3 is not even, but is 3 a multiple of 3? Yes. Okay, 4 is even, but is it a multiple of 3? No. 5 is even. 5 is not even, and is it a multiple of 3? Nope, so that's going to go out here. All right, 6 is even. Is it a multiple of 3? Yes, it is. That's an overlap. Okay, that's all my 6 numbers, so we can see right here. So now that we know that, we should be able to find the probability that it's either even or multiple of 3. All right, so we want to figure out the probability of even or a multiple of 3. All right, so the probability of being even is how many? How many do we have that are even? It would be 3 out of 6. Okay, what's the probability of a multiple of 3? Well, that would be 2 out of 6. Okay, there we have that. And then what is the overlap? All right, E intersection M. Oops, that's M, not B. It would be 1 out of 6. So your probability would be 4 out of 6 or 2 out of 3. So the Venn diagram can help you organize your thoughts, but be aware that when you're doing the OR, you have to make sure that you take out the overlap.